What's up, students? Hope you're having the best day of your life today. I want to go through a short free response question that is generally seen on the part 2 of the AP Physics 1 exam. This question in particular came from the Unit 2 free response questions that the AP College Board gives you under My AP Classroom. If your teacher has not unlocked those for you, just ask. This question is called Blocks A and B Collide. And you can see for Unit 2, they give 2. This is the second one in that string. When I'm going through this, guys, you want to pause the video, answer it yourself, and then come back for the solution. That'd be a great way to get some feedback on this video. First, let's look at the facts of the case. We have two identical blocks. They're on a horizontal surface. There's negligible friction. That's always good news between the surface and the blocks. They are moving towards one another with speed VA, V0, and VB is initially at rest. So this is at rest, and this has some speed, V0, and this is at rest, V equals 0 meters per second, and they have identical masses. In both figures, the location of the center of mass is identical to where X is. Okay, so this is going to be the center of mass for this entire system. And then they're going to use these two figures right here to answer part A. Let's take a look at part A. Okay, and here's part A right here, and it says on each of the dots, which represents the blocks, they are in contact during the collision. Okay, so this is while they're colliding. Draw a single arrow to indicate the direction of the net force, if any, exerted on each block. The net force must be represented by a distinct arrow starting on and pointing away from the appropriate dot. If the net force is 0 for either block, write 0 under it, and that'll be fine. Okay, so a little bit of confusion here that I see. Right now, when these two are colliding, Newton's third law says they are going to push on one another like this. And these will be equal and opposite, but this is an F net, and this is an F net. Something that we need to understand here, that the F net of the system is equal to 0 newtons. But that's not what they asked. They asked for the net force exerted on each block. So although these are equal, this will be, say, a negative net F net, and this will be an equal and opposite F net. The sum, because there's no outside forces acting, is 0. But in the contact time, they are going to push on each other in opposite directions. So the difference between the F net of the system and the F net on each block was a little bit of some confusion for students. Now, in the second part, they say, in the time that the blocks are in contact, describe whether the center of mass of two block systems speeding up, slowing down, or remain the same. They are going to remain the same, and this is just a definition that you need to remember. The center of mass remains constant when no outside net forces act on the system. It's as simple as that. When no outside forces act and things stay conserved, the velocity of the center of mass will remain constant. Even though these two blocks are going to travel away from each other, their center of mass is going to remain in the exact same spot. And here's where things always get awesome when they put things on an incline. Now, for the 2020 exam, guys, you do not need a calculator. So what are they going to do? They're probably going to make this 30 degrees because you know that for sine and cosine, you need to know the 30, 45, 60, and 90 degrees for each of these. These are things you learn early on in math that you should remember in your high school career. If you don't remember them, guys, the easy trick to remember this is just put a rad and then put 1, 2, 3 over 2. And then just write your angles, 30, 45, 60, 60, 45, 30. And remember, sine starts small and cosine starts big. So sine small. And then you just remember sine of 30 is equal to rad 1 over 2, which is a half. Sine of 45 is equal to rad 2 over 2. And sine of 60 equals rad 3 over 2. And then the opposite would be for cosine. The cosine of 60 is a half. The cosine of 45 is rad 2 over 2. And the cosine of 30. These are things that you should just know. I just want to review those quickly because on the 2020 exam, they're not going to give you 37 because you're not going to be required to use a calculator. But it's fair as an AP Physics student that you know the sine and cosine of these general angles. That being said, let's jump into part B here. It says the surface is tilted now 37 degrees. Now remember, there's no friction or negligible friction, which is great because that means there's going to be no work non-conservative by non-conservative forces. That's a good idea. These both have identical masses, and if I remember correctly, the mass was equal to 0.2 kilograms. So I'm just going to add that to the facts of the case. The blocks are each given a push to the instant they're moving towards each other. So let's be very clear. This to come up the incline, it was given a push. It's not given a constant push. It was kind of like thrown. Like when I throw a ball upward, the instant after it leaves my hand, it's in free fall. The only thing acting on an object thrown upward is gravity after I throw it. Granted, there was a force to begin with, but that force no longer exists. When they say I gave it a little tap-tap, a little tap-tap-a-roo, a little push up the incline, that force is not going to stay consistent. So when I look at this instant, the only thing acting on these blocks are Fg and the force of the normal. Same for this block, Fg and the force of the normal. If I had to draw a free body diagram for each one of these blocks, they would be identical. But now if I look in the direction of motion, I have Fg parallel, right? Which is equal to mg sine makes it slide. Same holds true here. I have Fg of this block, which is mg sine makes it slide. There's no friction, nothing else. So these are the forces and their components that are acting right now on this block. So when I look at the net force that's acting on the two block system, well, I look at this block and I say, okay, on block A, I have Fg parallel. That is the only force acting in the direction of motion. And for block B, it's the same. And because these blocks have the same mass, I'm just going to solve for one of them, and then I'm going to multiply by 2. So 0.2 times 10 meters per second squared times the sine of 37 degrees. The net force acting on this object is 1.2 newtons. The same would be on this one, 1.2 newtons. Therefore, the net force on the entire system is equal to 2.4 newtons. Let's now take a look at this last part. Okay, now it says at the instant that figure 3, the blocks are moving towards each other with the same speed. Okay, that was given in the diagram. We saw that. But they collide for now some time later. What is the speed of the two-block system's center of mass just before the two blocks collide? Well, because the net force on this system is going to be acting this way, down the system, right? And gravity is at outside force, so the velocity of the center of mass is going to be traveling down this way as well. But initially, the center of mass had a v naught equal to 0 meters per second. And they want to know, what is the final velocity going to be of the center of mass? That's essentially what they're asking us to do. Well, I know that A equals delta V over T. So A is represented by V final minus V initial over T. And I said that V initial is equal to 0. So I can say that V final is really just the acceleration of the system times the amount of time that it speeds up for. But I don't know A. Well, I can go back to my old expression of Newton's second law and say that F net equals ma. I solved for F net to be 1.2 newtons acting on the system, and the mass has a mass of 0.2 kilograms. Therefore, the acceleration of the blocks and the center of mass is therefore going to be 6 meters per second squared. So I can now plug this in and say 6 meters per second squared, and it acted for an amount of time of 0.5 seconds. I know the final velocity of this block is going to be 3 meters per second squared. I hope this video helped you guys. If it did, please give the video a thumbs up. Stay tuned for more solutions to short answer free response questions just like this that you're going to see on the AP exam. Have a good day, guys.
Hey, no, no, no.